Hey y'all, it's Miss Johnson. We're back at it again, calculus. Let's introduce the chain rule. So we've done the product rule, which is when two functions are multiplied together. We've done the quotient rule, which is when two functions are divided, right? We're now going to investigate the chain rule, which is when two functions are composed. So let's talk about what that means and what's going on here. Here's an example. Kick off with an example. If I've got a function x squared, the derivative is 2x, right? So it's something squared, and then its derivative is 2 times that something. And I'm saying it that way, that weird way, for a reason. And then if I have another function, say 4x squared plus 9x, fine, its derivative is 8x plus 9. Great. If I wanted to compose these functions, first off, function composition, this is not calculus, this is algebra. If we want to compose these functions, so f of g of x, what we do is we write g of x, or sorry, we write f of x, but every time we see x, we put parentheses. So something squared, that was f. Let me do it in red. Something squared. And then what is that something? The something is g. And now I just get to write what g is. All right, here we go. If we want to take f of g of f's derivative, right? If we want to take the derivative of 4x squared plus 9x quantity squared, right now, we don't really have a fast way to do this, right? Right now, we need to expand this. We need to do some unsimplification on here first. We need to do 16x to the fourth plus 36 times 2 is 72x to the third plus 81x squared. That math I did really fast was 4x squared plus 9 times 4x squared plus 9x. Right, I did this times this is 16, this was 36x cubed, this was 36x cubed put together, and then that was 81x squared. But that was the fast math I did. And then now this we can take the derivative of. Very good. The derivative is 4 times 16, which is 128. That can't be right. It's 64. Nice. Times x cubed. 72 times 3 is 216 squared, and then that's 162x. Great. You say, Miss Johnson, we don't need the chain rule. We got it. Like we did it. We just have to do more algebra than we want to do. All right. What about this question? Could we do this? Let's do 9x plus 4x squared to the 81st. Go. Right? If we wanted to do this derivative, it's worse because we'd have to be like, okay, well, we can just FOIL it out. We'll just write this 81 times, oh no, that seems like truly miserable, actual torture, right? So we really want a rule, a theorem for how to do this fast. Want to be able to do this fast. I'll say quickly because I'm pretty sure that's the grammatically correct version. And then I'd say, okay, what about this example? What's the derivative of sine of 4x squared plus 3? Right now, we have no idea. We want to be able to do this at all. Right? So for both of these things, we want a rule. We want a rule for f of g of x. Again, we want a rule for when there's a function composed with another function. And we want a rule when there's a function on the outside composed with a function on the inside. So these are both function composition rules. The way I like to think of these is like Matryoshka dolls or Russian nesting dolls. These things, right? The big function is like our f, and the little function, or the little doll is like our g. Ignore this one. So when we have f of g of x, it's like this one is hiding inside of this one. So we're going to do stuff to the outside one first. Then we're going to pop that sucker open, have the second one, and then do stuff to that one. That's how it's going. So again, Russian nesting dolls, it's like a little doll instead of a medium doll, instead of a big doll, and the dolls all break in half so you can like nest them. And that's how we're thinking of function composition. So for the chain rule, again, F is the big one, G is the small one, because F is on the outside. It's the thing we're doing on the outside. And then G is like the middle part. The way it works, and I'm going to color code this, we're going to say F is red, and we'll let G be blue. The way we take this derivative is we take the derivative of the outside, leave the inside as the inside, and then multiply it times the derivative of the inside. So in our Russian nesting doll of functions, we take the derivative of f, g is still inside that Russian nesting doll. Then we pop it off, have only g, and take the derivative of g. And g has no more dolls in it, because it's just x. Oh. Paint is glitching. Okay, that's fine. Let's do an example of that. Over here, minus, plus, plus. So now with our new rule, let's take the derivative of 4x squared plus 9x. So our new rule, right, the outside function is x squared. It's something squared. And the inside function is this 4x plus 9, or 4x squared plus 9x stuff. 4x squared plus 9x. Over here, I'm going to rewrite the derivatives just because we need them for our answer. G prime, boom, 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 boom. Our derivative said take the derivative of the outside, so it's 2 times something, 2 times something. But we're going to rewrite the g inside of it. And then we're going to multiply times the derivative of the inside. So again, our rule said when we do the derivative of f of g of x, which is what we have here, we do f prime of g of x times g prime of x. And just to be clear, the f prime is this part. That's the 2x. Rewriting g, we just rewrote it. And then we multiplied times the derivative of g. Then, if we want, we can FOIL this out. We get 4 times 8 is 32, times 2 is 64, and that's x cubed. We get 4x squared times 9 is 36, times 2 is 72, x squared, so that's part of this. We get 8 times 9 is 72, times 2 is something else. That's part of this. Added together, that's 216. And then 9 times 9 is 81, times 2 is 162, times x. So both of these derivatives are the same. Both methods are the same because our rule works, which is pretty good. This is equal to that. That's the chain rule. I'm going to do a couple more examples. This is now one we were not able to do at the beginning of this video, but now can do at the beginning, at the end of this video. I'm going to leave the chain rule up. I'm going to say that y prime is, first off, what's my f and what's my g? My f is my outside function, and my g is my inside function. So f looks like it's sine of x, because sine is the outside function. G of x is this thing. So we take the derivative, we say what's f prime of sine? It's cosine of something, rewrite g, straight rewrite the inside, keep the inside alone. We're doing Russian nesting dolls. You don't mess with the inside when you're messing with the outside. And then multiply it times the derivative of the inside, which we just use the power rule. Great. I'm not going to simplify it anymore. I think that's a finished problem. You also might notice that I've been putting parentheses around this. That's necessary because we want this to be multiplied by all of this. So we needed to have parentheses. Another example, sine squared x. We can rewrite this as sine of x squared. This is just a notation thing. So now when we're taking the derivative, we want to know what is f, what is the outside function, and what is g, what is the inside function. The outside function is the squared thing. The inside function is the sine. So the derivative is take the derivative of the outside. The derivative here is 2x. But rewrite sine of x, keep the inside the same, multiply it times the derivative of the inside. There you go. One more example, and then I'll tell you what to do for homework. Here, this part, in order to do the derivative, we'll have to use chain rule to find f prime. Overall, we need to use the quotient rule. This is a challenge problem, and we can talk about it in class if it's pretty confusing. But the situation that we find ourselves in is the overarching thing that's happening here is it's something divided by something. So we're going to use the quotient rule, which means it's the bottom times the derivative of the top minus the top times the derivative of the bottom. So low d high, high d low. We're going to take the bottom and we're going to square below. I'm going to rewrite the low. I'm going to rewrite the high. I'm going to rewrite the low. Bada bing. The derivative of the low is cosine. And now the really hard part is what's the derivative of this? You might notice that I filled in all the blue stuff pretty mindlessly, right? This was copying and pasting. This was copying and pasting. This was copying and pasting. And this, I have my note sheet right to the side of me. So I just got to write it down, right? This is the part where we have to think in this problem. So off to the side, scratch work. I'm going to say, what is the derivative of 3x to the fourth plus 2x cubed to the power of 5? And now here is where I'm going to use my new chain rule. The outside function is something to the power of 5. And my inside function is all this stuff. And I take the derivative. I take the derivative of the outside. Anything to the power of 5, the derivative is 5, that thing to the power of 4, where that thing is copying down the inside, is copying down 3x to the fourth plus 2x cubed. And now I'm going to multiply it times the derivative of the inside. I am not going to simplify this. I could, but I'm not going to. Now I'm going to go back up to my problem, and I'm going to regret writing it this small, as I always do. I'm going to move this like this. I'm going to rewrite it. Boom. And now, after my scratch work, I can write in 5, 3x to the fourth plus 2x cubed to the power of 4 times 12x cubed plus 6x squared, all in parentheses. And then when I say you don't have to simplify quotient rule problems, this is what I mean. That is a finished problem. Right? This is completely finished. Stick a fork in it, etc. That's a finished problem. But you see why the chain rule is useful, right? We couldn't have done this in a reasonable way without it. We couldn't have done these at all without it. That's the chain rule. Here's the deal. You're going to go into Schoology. Here's your assignment. There's going to be a quiz. It's going to say Introduction to Chain Rule. The only 2 questions are going to be, did you watch this video? Type in the code word, like it's a radio announcement prize-winning thing. That's not even how you spell word at all, y'all. I'm terrible at spelling. Code word. And then the next question is going to be, do you have any questions? The code word is, I don't know, alligator, right? And then the questions are, if you have any questions that you thought of when you watched this video, type them here so I can talk about them in class on Friday. So type out questions you have about this content. That's your only assignment today. The only assignment is watch the video. Congratulations, you've done it. So please just go take the Schoology quiz real quick. It's not long, but it's important that we've watched this video. All right, I'll see you on Friday. Bye.